Hello, Keith Rucker here at VintageMachinery.org. Guys, today we're back working on the metal planer restoration project, and where we left off on this last time was I had a shaft that we needed to make a replacement on, and that's what we're going to be working on today. I got over here set up in the lathe, getting ready to start on this project. Come along for the ride. So I'm set up over here on my Monarch 16-inch Model K lathe, and that's what we're going to be using today. And I've got a piece of shafting in here. So I did a little bit of looking around. I actually found a piece of old shafting out at the museum that's going to work out just fine. I don't know what the material is, but it was being used as shafting in the past, and that's basically what we're going to be using it for here as well. So we're just recycling a piece of old rusty metal, but all the rust is coming off, and we'll have brand new metal up underneath it. I've got it set up right now, and the way I'm going to do this job is I'm going to turn this shaft between centers, and I'm going to just take a minute or two and explain a little bit about why I'm going to do that versus just putting it in a chuck and turning it that way. I am starting out that way. I got to get my centers on each end, but the idea of when you turn a shaft between centers, so you have a center on both ends, is that you can take that shaft, you can take it out, put it back in, you can flip it around one end to the other, and it's always going to be turning on that center point in there. So the nice thing about that is once you get your lathe set up, you can move it around, you can take it out, you can put it back in. There's no having to come in here and indicate with the chuck and all this other kind of stuff to get it done. Yeah, I could put a 4-jaw chuck on here, move one end around, re-indicate it each time, or I could just put a center in there, and once it's set, and it's just a little bit easier way to go. Don't see a whole lot of turning between centers anymore. Back in the day, that was very, a lot of parts were turned between centers, particularly in production situations, because you could have different machines set up for different operations, and they would just take it off of one machine and put it on the other, and it was just put the centers in, and boom, you go. So it really has some advantages in some situations, and that's what we're going to do here. So first thing we got to do is put the centers in. I've got it chucked up with the 3-jaw chuck on this end. I got my steady rest out here supporting the end. What I want to do is go ahead and face the end of the shaft and drill a center hole. We'll flip the shaft over, do the same thing, then we'll put our centers in, and we'll be ready to start working. Anytime you're using a steady rest like this, you need to get the height set in here. And the way I did that is I just took a magic marker, marked an area in there where I could see a scribe mark, and then using a center finder like this right here, I'm able to come in, put that on there, scribe a couple of lines across there. Typically I'll scribe 3 lines rather than just 2, and the nice thing about doing 3 lines is usually, particularly when you have an older piece of metal, may not be perfectly round, may be a little bit beat up around the edge. What you can do is when those 3 lines intersect, there's going to be a little triangle in the middle, and the center of your shaft is going to be inside that triangle. So, and that's kind of what happened here. I don't know if you can see it, but there is a very small area in there where those 3 lines intersect. I just take my center drill, I line it up, I adjust it up and down to where I'm getting right there in the center of those 3 lines, and we should be ready to go. So first thing I'm going to do is face that face off now. I'm not worried about that line anymore. So let me get a tool on here. We'll get this face and then drill that center drill. All right, we'll come in here, touch off. I'm just going to feed in by hand, I think. Got just a little bit there left. All right, I think we got that faced off. Now we'll come in with our center drill. And that'll give us the center to work on. All right, so now what I'm gonna do is flip this shaft around. We'll repeat the operation on the other end, and we'll be ready to get her set up, go between centers. I'll open up my steady rest. Loosen up my chuck. We'll just flip this over. We'll tighten this back down. And because the diameter and everything is staying the same, this should still be set, so I'm not even going to worry about checking it. And we'll come back in and do the other side. So the next thing I want to do here is true up my drive center. Now, a lot of times people will use a hardened drive center that goes up in the headstock and use a drive plate. I don't have a drive plate for this chucks or for this machine, so I'm just using a 3-jaw chuck. And what I've got here is just a regular piece of metal. It's not hardened or anything like that. But because I'm going to be putting it in the 3-jaw chuck and driving my dog off of one of the jaws on the chuck, I need to true this up. It's a quick and easy thing. So I've got my compound set to 30 degrees, which is that nice angle across there. And we're just going to true it up. Remember, with a 3-jaw chuck, that each time you put it in there, you're going to have a tiny amount of run out, maybe a thou or two, maybe less than that, but we want this to be right on, so we're just going to true it up real quick. So I'll come in here, we'll touch off on there, and I'm just barely skimming across there. And that'll take any run out that was in there, and it will have it running true. As long as I don't take that out of the chuck, it'll run true. If I take it out of the chuck, I need to redo this step right here. All right, there we go. All right, we got our shaft here. I've already put a drive dog on there. I'm up on that dead center in the headstock, and I'm going to pull my live center in down here in the tailstock. The difference between a dead center and a live center is that this one doesn't. This one is going to turn with the chuck. This one is live. It's spinning down here. This one here does not rotate, so it's dead. The chuck is rotating, but the center doesn't rotate. This one here free spins. So got that set up. We should be ready to go here. We should be set up here now, so the shaft is between the centers. Again, I can flip this thing around, no problem. It's going to stay running true because it's going to be running on the center of rotation. The drive down here on the end, because again, there's nothing actually attached to the chuck. You put a drive dog on here, that's just running up against the chuck there, and that's what's actually turning the shaft, is the drive dog. And with that, I think we are ready to start turning this. So what I'm going to do is figure out what my largest diameter is, a section in the center here that the gears go up on. We're going to go ahead and turn it to that diameter. Of course, I won't be able to turn all the way to the end, but again, the beauty of turning between centers is that we will finish this side of the shaft. We'll flip it around and drive it from the other end. So we'll figure that out in a minute, and basically we'll just probably turn down to somewhere in here and stop, because we'll turn that from the other side. All right, let's start making some chips after all this setup. All right, so our shaft here is 2 3/16 inch in diameter. The size we're going to is 2 1/8. So we got about 60 thousandths, actually 62 1/2 thousandths that needs to come off of this to get to the nominal size. And there's an area in the middle of the shaft, and you can kind of see what we're going for. This is this diameter here. I need to turn it down at least to about right in here. And I think what I'm going to do is I'm going to take a light pass, clean it up, and then measure it and see if we got any taper in here. Now, when you're turning between centers, you can usually adjust taper by moving the headstock left to right. So we will come down through here, check it, see if there's any taper, and I'll probably try to fine tune this to make sure we're getting a nice straight cut all the way down. So Let's just come in here. We'll touch off. I'm just going to take about 15 thou, I think. Taking a rather coarse cut right now, but that's fine for what we're doing. That should be plenty far enough. I want to check this for taper because we can adjust that with our tailstock. So let me get a good measurement here on this end, and it looks like we're about 175. I'm going to go in here roughly to the center and measure again, and we're about 178. So we're about 0.03 larger in the middle than we are on the end. So to adjust that, again, we can adjust the tailstock in and out. So it's bigger in the middle, smaller on the end. So that tells me that the tailstock is too close to me in this direction. And if we move the tailstock back, it will actually straighten that out, because in theory, the lathe is cutting straight down through here. If this is toward me this way, it's going to be smaller on the end and bigger on this end. 0.03 distance to the center. I'm going to make an assumption here that if we took it all the way to the end, it'd be 0.06 bigger on the end. So that's 0.06. We need to do half of that, which is back to that 0.03. So what I need to do is I need to move the tailstock away from me 0.03 of an inch. So I've got an indicator set up over here. We're going to make a little fine adjustment to it and see if that doesn't straighten it out. So here's my indicator. Again, we want to go this direction away from me 0.03. So I'm just to verify here, I'm going to pull this to me. The needle's going toward the plus side. I actually want to make it go 0.03 to the minus side here. So the needle needs to come to me 3 thou. There are 2 set screws, one on this side and one on the other. They're basically jamming this in. There's a keyed way here that this thing slides back and forth on. So what I need to do is make adjustments to these down here. I just moved it 3 thou right there. I'm going to tighten the other side up. Just a touch more right there. Okay. So now this tailstock has moved over 3 thou. I'm going to make another light pass. We'll take measurements again and see if we were able to straighten that out. All right, I'm going to take another light pass here, probably just 10 thou again. I'm only got to take 62 thou off this. I want to get my adjustments right before we start taking off any serious metal, just to make sure we get everything fine-tuned, which is why I'm taking light passes here, guys. You know, if we had a couple 100,000 ago, I'd be making 50,000 passes on these adjustments here. So I'll tell you what, we'll go 15 thou. I sped my lathe up, the RPMs up just a little bit. Let's take it on down. Getting a little harmonic in here. Started getting a little chatter. I think my cutter may be getting dull. Let me swap that out. All right, I did a little playing around off camera to come up with a solution for this chatter that we were getting down here. One of the problems you often run into when you're turning a long shaft or something like this is that you get vibrations, particularly the farther you get away from a point of contact. You can get vibrations in there. A lot of times you can get around it by playing with your feeds and speeds, changing your cutter, various different things. I wasn't having any luck. So what I ended up doing was just putting my steady rest in here. And what this is doing is it's just giving some support, and basically it's dampening those vibrations out there in the middle, because now I've got a shorter area here that I'm actually turning for vibrations to develop in. So I'm taking another little cleanup pass here. I'm going to make some measurements, double check, make sure that we got our taper right, and then hopefully finish turning this area down here to the final dimension. All right, we're going to check this diameter now. Let's see. So we're about 150 there. Right on 150 there. And right on 150 there. So it looks like we got our taper issue squared away now. And we've got about 25 more thou that we need to get out of there. So we'll go ahead. Probably what I'll do is take a 20 thousandths pass and then come back and make a cleanup pass for whatever's left. So let me dial that in. 5, 10, 15, 20. Come on across. Letting it come on across. A lot of people ask about the oil and the smoke that it generates. Guys, when you see that smoke coming off the part, that is the heat escaping from the part. In this case, most of the smoke most of the heat is escaping in the form of smoke, and that's a good thing when you're machining. We're trying to keep the heat out of the part. And that's the nice thing of using some of this high sulfur oil like we use, is we get that heat out with the smoke. All right, let's see where we're at on this diameter. We were at 150 before, we took 20, so we should be on 130. Perfect, bingo. So I got 5 more thou to come off of this. I'll dial that in. And we should have that first diameter ready. So let's see here. All right, that should be it right there. Let that work its way across, and we should be good to go. All right, we got this down where we need for it to be on 125. Down here, 6 inches in. This needs to go to 1 3/4 inches. So 1.175. So let me go ahead and start eating away some of that material. This down here will be a bearing journal. This will be the area that the gears sit in on it. So touch off 10, 20, 30, 40, 50. We're just going to hog some material off. I'm going to play around here and see what kind of depth of cut I can get away with without getting any chatter. I'm starting with a 25 thousandths cut, which is a 50 thousandths total removal on the diameter. And that appears to be cutting really nice so far. Starting to hear a little bit of a hum in it. I don't know if y'all can hear that, but that's telling me it's picking up a little bit of harmonics in there. I'm probably not going to try taking more than that. If I was to move my steady rest down here closer, it'd probably be fine, but I really don't want to put it on this surface I just turned. So we'll just take our time and do these 25 thousandths cuts. The lathe will take a lot more than that. I'm just worried about the harmonics. Should be getting real close here, and we're about 10 thou above, about the same there. This should be our last little bit to take off of here. I'm only taking about, I think, 8 thou off of this diameter. It should put us right on the money for 1 3/4 inches. And again, this is going to be a bearing journal down on this end. This will be running on a Babbitt bearing. This dimension, it needs to be pretty darn close, but honestly, the bearing itself has got some wear in it. If it's a little bit on the oversize, it's probably not going to hurt anything. The old shaft had worn down about 10 or 12 thousandths. The The bearing itself is worn a little bit oversized, so there was a little bit of room in that other one. And I'm just trying to get this back to the original diameter, and that little bit of extra space in the bearing will be perfect for the oil to fill up, and it should run just right. So had a lot of chatter on this cut here. As we got a little bit farther into it, it kept getting worse and worse. I was able to keep making that 50 thousandths cut, but the last couple of passes I've been making relatively smaller cuts just to try to get that chatter out of this particular cut. This long shaft is proving to be difficult, but so far we've been able to get around any issues with it. All right, I'm gonna take a cut down this back side to get a nice square relief in there. And that should do it. So we're within about a thou there, right on the money there. I can see a little bit of a, even though we were taking a real light pass, I can see a little bit of harmonic in that. So I'm just gonna come in here with some fine emery cloth. According to my measurement, that was about a thou or a half a thou over on that side anyway. That should smooth that out. Yeah, we're good there. Put a couple of chamfers in here just to break those corners. All right, I think we're good. I'm gonna flip this over and we'll get ready to start working on the other side.